On today's video, we're gonna take another run at gold-filled jewelry. I posted a video not too long ago where I tried some crazy chemistry, tried to recover the gold and silver from gold-filled jewelry, and it didn't work very well.
I don't see hardly anything there.
So now AI and I have been talking, and we've got a new plan that should work to recover gold and silver without using acids from this gold-filled jewelry. So let's give it a try and see if we can recover our gold. The little bead that we got in the cupel is not big enough. Now here is the secret sauce to this whole thing. Here's some of the stuff we got. Harry worked through all this, clipped all the magnetics out, and kind of sorted it into the different karat gold. We got some higher karat gold here, and this is more of the junk and the stuff that probably has some stainless steel and will be harder to recover. But what he also did was picked out all the magnetics. And the magnetics in gold-filled jewelry are typically a lot lower grade. They're more gold-plated than gold-filled. And see, all these you stick to a magnet to some varying degree, right? And so with our experiments, I want to use the magnetic stuff because if I screw it up, we're not losing nearly as much gold as we are with some of this higher grade 12 and 14 karat gold filled stuff. So let's get started on our experiment here, but I want to give you a little bit of chemistry first. So real quick, gold fill is super heavy, thick gold plating, typically on brass or copper base metal jewelry. There is a significant amount of gold in there, somewhere in the 2 to 3% typically. So in 1.5 kilograms, there's about an ounce of gold. So there's definitely enough gold in there to recover. Now, the trick is, a lot of this is done by using acids, which is expensive, it takes a long time, you have a bunch of waste to deal with, all that kind of stuff. And I'm a fire guy. I like to use fire, I like to smelt stuff and melt it down and recover our precious metals that way. The problem with that is there is a ton of junk in there, iron, copper, zinc, that we got to get rid of, and that's typically done with acids. My goal is to oxidize all that stuff away and concentrate all of that gold and silver into a smaller button that we can then use acids on to refine to pure gold and silver. The trick is, how do you oxidize that much metal without losing a bunch of gold and silver or making a huge mess and taking a bunch of time and a bunch of propane and a bunch of fuel? So here's my idea. We're gonna take our gold fill. Again, this is all the magnetics, so it has a lot of copper, so it has a lot of iron in it, which can still have a significant amount of gold on it sometimes, especially these little clasps. In here, there's a little spring or there's a little something in there that pulls to a magnet, but these little clasps are typically heavily gold fill still, so those are definitely worth recovering the gold off of. The problem with iron in particular is it causes trouble with your acids. Well, let's see, how much does all this weigh? Oh, perfect. So there's 50 grams. So that's what we're gonna start with on our little experiment here. Now again, the problem is the iron makes a real problem with your acids and your nitric and all that kind of stuff. It makes it hard to filter and causes a mess. So a lot of guys that do acids don't want to deal with this at all. And if I can figure out how to recover this, then the rest of the gold fill shouldn't be a problem. So now for our flux. This is a pre-mixed flux. It's about 65% borax, 20% potassium nitrate, which is going to be our oxidizer. That's going to help eat up all the copper, zinc, and iron. And the rest is a little bit of silica and soda ash. I'm going to do a 3-to-1 ratio, so I'm going to add 150 grams of that to ensure that we have enough potassium nitrate. We should have 60 grams of potassium nitrate, which should be enough to eat up most of the copper and base metals. Now here is the secret sauce to this whole thing. And I went back and forth with AI on this a long time, and it assures me that this is the right answer. This is bismuth oxide, and there's a thing called the metal reactivity chart, and it shows how reactive metals are at room temperature. And copper is way at the top of the list. It's right under silver. But we're not dealing with room temperature. We're dealing with 2000 degrees in our smelting furnace. And apparently, copper at that temperature is more reactive with oxygen than bismuth is. And so I'm gonna add in 30 grams of bismuth. What did I put in, 30 grams? About 30 grams, I need about 33. I'm gonna add a couple more. But the bismuth oxide, when it touches the gold fill and the copper and the iron, it will turn into bismuth metal, and it will oxidize the iron and the copper and the zinc, and that will go into the slag. And so what we should have is we should have all this base metal get oxidized away. The bismuth will reduce, collect everything at the bottom, and then we'll have all that junk in the slag and just our precious metals in the bottom with bismuth that we can get rid of. Now let's mix this up so it's evenly distributed. You want that bismuth oxide evenly distributed through the flux so it can react with all the different areas of the gold fill. We should have a 30-gram bismuth button, unless there's so much oxidizer in here that it starts oxidizing the bismuth. But that might happen. Do I just want to pour that in there? I think what I want to do, let's do this. Now I'm breaking all the rules here. I'm going to put some right on the bottom. This is that flux again, so we can have some stuff right on the bottom. And then I think we just kind of let's see how this works. Can I do it? Can I pour and drop at the same time? The trick is you want all this stuff available or touching so that the chemistry can happen. So there's our charge. Let's go put it in the furnace and see what happens. This is a big experiment here. All right, right over here to our furnace. Let's get it fired up. All right, now one of the other things we don't want to do is get it too hot. I want to make sure that jewelry doesn't melt. I want the oxidizer and the bismuth oxide to eat it away. So I'm not going to ramp it up to 2000 degrees real quick. Copper melts at about 2000, brass 1800 degrees. I'm going to try and keep it about 1500 degrees Fahrenheit and try and let those oxidizers work their magic on that stuff. Because if it melts down into a puddle at the bottom, you don't have any surface area, and the oxidizer all goes out the top of the crucible. So we're gonna heat it up slow and hold it until hopefully all that stuff just sinks down and gets eaten away into the slag. Well, I couldn't get it on camera very well, but as the oxidizer frothed and boiled, it covered up the whole charge, right? I couldn't see any of the jewelry in there. And then as the oxidation process was done, it all calmed back down to a nice, quiet smelt. And the jewelry started poking up through the flux again, through the slag. And I could see the bismuth eating that stuff away. And after about 2 or 3 minutes, all the jewelry was eaten up and fell below the surface of the flux. And it's only 1450 degrees, 1500 degrees Fahrenheit in there. So I know the jewelry's not melting. I think our bismuth oxide is eating away all that iron, eating away all that copper and that zinc, and it's doing its thing. It's collecting the gold down to the bottom. I'm really excited about this. This could be a big deal if this works. I'm not sure if this first one's gonna work perfectly. We might need to add more oxidizer. We might need to add more bismuth, but from what I'm seeing in the melt, it's working really, really well. Now I'm gonna let that go for another 15 minutes or so. All the oxidizers used up, and we're just gonna let that bismuth oxide work and do its magic there. And the cool thing about this is if the bismuth was reduced by the copper to bismuth metal and copper oxide, but then the bismuth metal was then reoxidized by the oxidizer, it goes into the slags and oxide, but as soon as it finds another piece of copper or iron, it will reduce again. So even if we oxidized a bunch of our metallic bismuth in the frothing and the oxidation process, it is less reactive than copper and iron is with oxygen at these temperatures. So when this whole process is working itself, the bismuth never gets oxidized as long as there's still iron and copper that it can essentially burn, replace the oxygen with, and reduce itself to bismuth metal. A little bit of a complicated project here, but hopefully you guys are following along. The end goal is obviously to get gold and silver at the end. Good pattern on there. A little more metal than I hoped for, but we'll see what it looks like and how much it weighs. Well, I can tell you right now, we did something, because if you look at that slag, it is totally black, which means iron oxide. It means we oxidized a bunch of iron, which is great because that's the initial problem we had with that stuff, because it would have screwed up our wet chemistry process if we tried to go right to wet chemistry. So if we can at least oxidize all the iron out of there, that'll be a big win. My hope is that we can oxidize all the other base metals as well. We might need to add more oxidizer, we might need to add more bismuth. I'm not quite sure yet, but when we see that bead, we'll know. All right, moment of truth. I'm liking the look of that slag. Okay, here we go. There's our bead. A lot of copper in there still, I can tell. Nice brown, kind of reddish slag, so we got some copper in there. It's always interesting when I pour, I think there's a reaction with the cone mold right at the interface there, and maybe it drops some of that copper out that we oxidized. But that's a really nice looking slag. Let me get this cleaned up here a little bit and we'll weigh it. Kind of interesting, it looks real silvery where it was still on the slag, where it looks like it touched the side of the cone mold, it looks more coppery. But let's see what happens here. 42 grams. That's really not bad at all, actually. What that, if everything ran to completion, that means we have 30 grams of bismuth in there, some copper, and then whatever precious metals we have. So we could probably use a little more bismuth oxide or a little more oxidizer, but I'm really, really happy with that. We started with 50 grams. I added 30 grams of bismuth oxide, which would reduce to bismuth. And we got 42. I'm gonna try and throw that right in the cupel, I think. Is that what I wanna do? I think so. Let me think about that for a minute, but I'm really, really happy with that. All right, here we go. Preheated cupel. There's our 40 grams. That cupel should hold about 60 grams worth. So my hope is that if I have to add a little bit of bismuth later, then we can still absorb all those oxides. I'm gonna watch this for a second here because I should be able to tell if it's mostly copper by how fast it melts. So we'll keep an eye on this, but I'm very excited. All right, well, that did not work very well. It's mostly copper. it's super solid. It's not working. It's solid at high temperatures. It's not oxidized with bismuth. So that means it's mostly copper. So we have another little problem to solve here. All right, let's see if I can recover this from this Q-Pel. All right. Try something else. Give me my metal back. There we go. That's kind of cool. That's inside of a Q-Pel. The oxides just get soaked in there. All right. Now we got to deal with this. First thing we got to do is increase its surface area so we can deal with it a little bit better. So back in the furnace. All right, corn flaked it up, lots of surface area. I actually wanted to check one thing here. I didn't do it, whoa, I didn't do it on the big button. Is this stuff magnetic at all? No. So there's nothing in there that's magnetic anymore, which is awesome. So that's good news. But now we've got our copper and bismuth with a huge amount of surface area again. We're gonna play around with this one more time. All right, what I'm gonna do is I'm gonna take our slag from our first smelt. There's plenty of borax in here to absorb the oxides that we need if we can make them. And if the bismuth oxide is still in here, if it didn't work its magic on the copper, that's still in here. The iron oxide's in here, it's locked up in the slag. So I'm gonna add all that back in. I'm gonna add our freshly corn-flaked copper here. I'll get that cleaned out just a little bit more. Then I'm gonna add a bunch. I don't know. 40, let's see, how much is that? 50? 50, 55, 53? 53 grams of potassium nitrate. And we'll get that all re-smelted down, see if we can make that a little bit less than our original 42 grams. I have added bismuth to it. I added some bismuth in the Q-Pel, and I added, so it's I don't know, I don't have a good weight on it. We'll see. I want to get rid of the copper. Let's see if we can get rid of the copper. All right, let's see what we got here. Sorry, the neighbor's mowing their lawn, so you'll hear the lawnmower in the background. Okay. I did see a little tiny bit of metal come out. Uh-oh, my glasses. There we go. Hey, that looks encouraging. Well, we oxidized a hell of a lot of copper away. That's what we got. I don't know if I'm seeing things, but it's almost gold colored. All right, well, let's get a weight on that. Well, let's see. 50 grams should have about a gram of gold and a gram of silver. All right, we're gonna try something here. While that bead is over there cupelling. I've got 53 grams of gold fill weighed out. I'm gonna add, essentially do the same thing we did the first smelt, but I'm not gonna add any bismuth. I think the bismuth may have kind of screwed us up. So I'm gonna add a little bit in the bottom like I did last time. I'm gonna dump in the gold fill. Let's see, what do maybe I wanna do most of the flux in there. So the oxygen is below it. Dump our gold fill in there. Put more on top. I don't know if that's gonna work. Because it's so big, we don't need, you know, if I shake it, it's all gonna go to the bottom. So let's try that and see what happens. Okay, let's see what this one looks like. Oh, there it comes. I saw the button when I poured it. It seemed pretty small. All right, well, let's see what we got for weight here. Start with 52, I think. 38. 52 to 37, 38, somewhere in there. So we did reduce some. Not as much as I hoped, though. All right, so I'm having a thought here. Our first experiment, when I corn flaked it and resmelted it down, we lost almost all of it. This one we lost, I don't know, 30%. But the jewelry is pretty thick, right? I mean, those chains and those little clasps and stuff, that's a lot of mass for the oxidizer to eat through. So I'm gonna try and cornflake this button, resmelt it just like we did, and see if I can collect the gold and silver with the copper. But now I'm wondering if it's more efficient to melt the gold fill first, cornflake it, and you might get most of the base metals eaten up in one smelt. But let's continue with this guy, see if I can get this all the way down to a button we can cupel or maybe scorify after cornflaking it and then resmelting it with the same potassium nitrate flux. Melted through my bucket. Well, it's just one fight to the next here. I got a hole in my bucket. I got 34 and another 3 grams easy in there. So we still have all of our copper. It doesn't look like it flaked so well. I think I need to drop it from higher to get more surface area. So let's go check on that other one that's in the cupel furnace and see if we even have any gold in this stuff. Here's what we got. No, that doesn't look done yet. Try that again. Well, that little button keeps going there after I add a little bit of bismuth. We'll go with this next copper experiment here. So the idea here is we've cornflaked the copper. So we have a lot of surface area. We're going to use the same flux recipe. I added actually 10 or 15 more grams of potassium nitrate to it. for a little bit more oxygen. Let's put it back in the furnace and see if we can get a small copper bead that we can then cupel and check for gold. Oh man, I feel like this is just a video of me pouring copper from a crucible to a cone mold and then put it back in the crucible and pouring it back in the cone mold. But hey, we're learning a lot of ways not to do it, so that's something too. It occurred to me that if the iron and the zinc are the big problems with the wet chemistry part, if I can get rid of those with the smelt and get it down to just copper and gold and silver, the copper can easily be refined away in a copper cell with electrowinning and that kind of thing. And I've done that before in a couple videos. So there might be a hybrid model here. I'm not quite sure. The little bead that we got in the cupel is not big enough. That's not as much gold and silver as there should be. So we lost some gold and silver there. And then the one that I just poured, it still looked pretty big. That was a pretty big looking bead. So I don't think this video is going to be a success either. This gold-filled jewelry is really causing me fits. If you have any suggestions, leave them down in a comment. I will keep track of those and see if anybody else has some better ideas, especially for the irony parts of the gold fill, because I know there's still gold on that stuff. I'd like to be able to process that. If not, just all of it. I'd love to just put it all in a pot and pour out something that we can use or deal with. So let me know what you think. But we'll wrap this thing up here in the next couple of shots, I think, and figure out what we got and what we didn't get. Before I pour it out, can you see how vibrant blue that is? That's really neat. Let's see what's in it. Huh, it was just blue right on the very edge there. The rest of it's black. Huh, interesting. All right, what do we got here? All right, where's my scale? Oh look, more copper. What is this way? We start with 37 grams. 34 grams. Okay, that did not work at all. Well, here's our sad, tiny little bead from our first smelt. That's not a good sign. Let's see what it weighs. 0.2 grams. We should have got 10 times that much. We should have got about 2 grams of gold and silver. So that didn't work at all. We got copper and we got very little gold and silver. All right, well, failure number 2 on this whole gold-filled jewelry thing. I am not sure where to go from here. I got to think about it a little bit, and acids might be the answer. But if you have any ideas, leave me a comment down below. We got to get RB as gold, and this way it doesn't work. So thanks to everybody for watching. We'll see you on the next video.